Law of conservation of energy in the case of simple pendulum. Make it fast. We'll complete it and we'll go to the numericals. We'll solve it, and then next class we'll go with directly the next concept, periodic motion. Okay. So observe here, everybody. So what is law of conservation of energy? In the yesterday's class, we have proved that it will state, what is the statement of law of conservation of energy? Anybody? Energy can neither be created nor destroyed, but it can be converted from one form to another. So that is only based to called as law of conservation of energy. Again, I'm repeating, energy neither be created nor be destroyed, but it can be converted from one form to another. That is what in yesterday's case, in free fall case, if you all notice it, in free fall case, if you measure the energy, total energy of a body in any three different cases, always the total energy, that is what E means, what mechanical energy, is remains constant. Am I right or wrong, guys? All of you, at every point we have been proved that energy is always remains constant, means it is conserved. That is what law of conservation of energy. Is it right? Please respond. Correct or not? So in the case of simple pendulum also, so we are going to prove that law of conservation of energy in the case of simple pendulum. So what is this experiment, everybody? Simple pendulum. Okay. So basically for creating oscillations and studying the properties of a wave and all, we will use the simple pendulum. Nothing is there. There is a one rigid surface and one long thread will be there, and at the end of the thread, they have been attached one metal bob. So that is only we used to called as simple pendulum. Now you can take the simple pendulum to any side, either your right side or your left side. Take it to certain height, and if you leave it, so that it will be keep on doing the oscillations. Am I right or wrong, guys? All of you? Like even wall clock you might have. So now if you notice it here, so the law of conservation of energy can be verified in the case of simple pendulum also. So consider a simple pendulum suspended from a rigid support. So this is the support we used to call as what support, everybody? Rigid support. Okay. So just it is present like this, middle one alone. Now, position A, wherever it is there, this is position A, and this is position B, and this is position C. Position A is the mean position of the pendulum bob. What is this position, everybody? All of you respond. Mean position of the pendulum bob. Pendulum bob. This only called as a bob. Okay. Now, if the bob is displaced towards to the right, if I taken to the towards to the right, it will comes to the what position, everybody? If I displace towards to the right, so what position will come? It will comes to the B. And if I displace to the left, it will goes to the what position, everybody? It will goes to the position C. On the C. Now, if you notice it, it has only potential energy. If you notice it, it has the potential energy as well as velocity of the bob at the extreme position. If it will goes to the extreme at this height, it is having only one energy. Can you tell me? Above from the ground, its velocity becomes zero. When the bob is keep
Gravitational
on moving,
potential energy.
see that if the bob is keep on moving in this direction, so it will reaches to the maximum height. So when the ball is reaches to the maximum height, we all knows that something is become zero. What is that?
Velocity.
Final velocity becomes zero. If the velocity becomes zero, so at this height, body is having only one energy.
The kinetic potential energy becomes zero.
Yes, so that it has only one energy at that time. What is that energy, girls? Agalya? It has only potential energy. If it will comes to the C point also, here also it is only the same height above from the ground. So here also its velocity becomes zero. So here also it has only one energy. Anybody can tell me what is that energy? Here also it has only potential energy due to the position. So it has only potential energy as the velocity of the bob at these extreme positions, B and C is called as what positions? Everybody? Extreme positions.
Extreme
A
position.
is called as mean position and B is called as extreme position. So this at the extreme positions, the velocity of the bob is becoming zero. So that at this point it has only potential energy, and at this point also it has only potential energy. Like yesterday, when the bob is falling, when the ball is falling, potential energy lost by the body, which is equals to everybody before reaching the ground. I told you yesterday before ending the meeting. Suppose the body lost 10 joules of potential energy. Potential energy lost by the body is 10 joules. Means kinetic energy gained by the body is how much?
10 joules, sir.
10 joules. Understanding? So the loss of energy in the one form will be equals to the gain of energy in the another form. Am I right or wrong, guys? Everybody? So that is what it is. So that is why energy neither be created nor be destroyed. It can be transferred from one form to another. So when at extreme positions, this is having only potential energy. When it will comes to this extreme position also, it is having only potential energy. Now, can you tell me on the way, what is the energy present? On the way, for example, Bob.
Kinetic energy. Potential energy is in absence.
Yeah, potential energy is converting into what energy? On the way. It will be converting into
Kinetic energy.
kinetic energy.
Kinetic.
Now, the bob is traveling. Now you tell me it is coming down. Velocity increases or decreases at this point, mean position. Velocity maximum or minimum? Velocity maximum or minimum? Everybody.
Maximum.
Maximum. If it is again going up, velocity decreases or increases?
Decreases.
Velocity decreases. Understand, everybody? So at point A, it has maximum velocity. So that you can notice a. So as the pendulum bob moves towards to the mean position, either from C to A or B to A, mean position, what will happen, guys? The total energy converted from the potential energy into what energy? Total potential energy converting into kinetic energy. Now, again the bob is moving from A to B. Then here what will happen? Total kinetic energy converting into what? Reaching to the B.
Potential energy.
Potential energy. Now, again from B to A.
So
Reverse.
during the motion, it convert
It will
potential
convert
energy into
potential energy
kinetic.
into kinetic energy. Now you tell me, again B to A, what energy transformation? B to A, potential energy converting into kinetic energy. Now again A to C, what will happen? Reverse. A to C also, what will happen? Kinetic energy converting into potential energy. I hope everybody clear, all of you. So always energy remains constant. Energy neither be created nor be destroyed. So the total energy is converted from the potential energy to kinetic energy, and then kinetic energy to potential energy. So whatever the energy possessed by the body, it is remains again and again and again, it will be remains constant. So in between the mean position and the extreme position, the energy of the bob is converting into what? On the process. At the mean position, it has only kinetic energy. On the extreme positions, it has only what energy? Everybody. At extreme positions, it has only
Potential energy.
on the way, what is happening? On the way, what is happening? Everybody.
Sir, kinetic energy is
Converts
changing
into kinetic energy, sir.
The kinetic energy is converting into potential energy, or potential energy is converting into kinetic energy. Energy transformation is taking place. You all understanding, guys? All of you? Yes?
Sir.
Yeah. If you go to the 12th class, you will be having a derivation for this also. Mathematically, we have to derive it and we have to prove it at every point energy is remains. Energy is remains conserved. Okay. At B point and at A point and every point, okay, the energy is remains conserved. Even we'll prove it also mathematically. So yesterday's class, for free fall case, mathematically we have been proved. Am I right, guys? Everybody? Yes or no? All of you?
Yes, sir.
Yeah. So that is what you have to remember it. So this is what conservation of energy in the case of simple pendulum. If you need derivation even now itself, you have to learn some inclined surfaces and all. As now, if the body is at incline, see here. So then I taught you people, you might be remember, if the now gravity is acting downward direction, like weight of the body is acting downward direction. So that here theta, you might be remember mg cos theta, mg sin theta. For inclined surfaces, I have taught you.
Yes, sir.
So like that, very
Sir.
complicated one. So it will be very, very tough for you to understand. So that is why let it be is not required. Only you learn that if they will ask you in the exam also, prove that law of conservation of energy with any one example. With what example you can prove, guys? Yes, I taught yesterday.
Free
What
falling case.
free falling?
Free falling body.
That is what I'm expecting. So everybody will follow that and free falling case. So kindly finish it. Okay. So learn that example. Yesterday, those who are absent also, please go through that and you can learn it. Okay. Now, so this is what conservation of energy in the case of simple pendulum. I hope everybody clear. Any doubt, please let me know. Understand, guys? All of you?
Yes.
Yes. So now let us go with the next questions. Numericals will solve something few today, and then next class we will go with directly periodic motion. So periodic motion is over. This pendulum case only, and then one formula will derive. If it is over, then this chapter is almost completed. So tomorrow we'll study what is the simple pendulum, what is the simple harmonic motion, and periodic motion. That is all the things, angular displacement, length of the pendulum, this all the things we will discuss. And now we are going to study, let us solve the numericals and then we'll proceed. So write the first question. What is the work done in bringing a moving body? All of you write it. What is the work done in bringing a movie? Science exam, I think the third exam, I think. Okay, ma?
Yes, okay.
Yeah. Science exam is in third, only second chapter. We have 2 more weeks. Of course, this week also, if I don't have a class on Sunday, definitely I'll take. Okay, va? So we'll practice it. No issues. Yeah. So this is the question number 1.
Sir.
Yes. Yes, please.
Sir, Sunday will be going tour, sir. Can you take on Saturday, sir?
Yeah, I'll plan. Because Saturday I'm busy in the 10th class. That's the reason. Okay. So we'll discuss and we'll
Okay, sir.
see now.
Thank you.
What is the work done in bringing a moving body to rest in a distance of 2 meters by applying a force of 4 newtons? So what is the answer, please? You can directly say work done is equals to what is the formula? Force into displacement. Am I right? So force is equals to, they have given 4 Newton and displacement is equals to 2 meters. So what is the work done, everybody? Work done is equals to 4 into 2, which is equals to 8 Newton meters.
Wait.
We all knows that 1 Newton meter is equals to how many joules? Everybody, 1 joule.
1 joule.
What is the work done?
8 joule.
8 joules. Solve it. Next. Completed, everybody? All of you completed?
No, sir.
Finish it. So this is the next question. You have to solve. First you try, give me the idea and then I'll proceed. A laborer climbs up a staircase carrying a load of 10 kg on his head. The staircase has 20 steps and each step is 0.2 meters high. Find the work done by the laborer in carrying the load. That is what it is. So keep it in mind. Now one more point I want to say you. For example, notice it. If there is a building, okay, now to climb this building, one boy has been directly climbed up and he reached here. And another boy, he started following the different path. And finally he reached here. Now, can you tell me both are here? What is the potential energy possessed by this them? Both, is it both are same or both are different? This is the path 1 and this is the path 2. Now you tell me. Anybody? What is the potential energy? Both are at the same height. So that what is the potential energy possessed by them? Is it same or different?
Different, sir.
Different. No. So both are at the same initial point and both are at the same final point. The initial point and final point is same. Remember, potential energy is independent of path. Independent of path. Do you all understanding? So path, it does not depend. Only it will depends on initial point and final point
Final
of
point.
the object. So irrespective of the path, the potential energy is always independent of the path. Only it will be decides initial point and final point. Clear, everybody? All of you?
Sir.
Yes.
Yes,
It
sir.
will not depend on the path. Keep it in mind that always. Okay, guys? Yes, all of you. So that is
Yes,
what,
sir.
because see that, for example, when he is climbing from here to here, he will possess the what energy? Potential energy increases or decreases? He is going away, up, increases. Understanding? And he is traveling horizontally. Horizontally means potential energy remains constant. Am I right or wrong? Everybody? Yes, please.
Yes.
In our terrace, if you travel 1 kilometer also, what is your potential energy? Remains constant. Understanding, Amma?
Constant.
And again, he started rising from here to here. His potential energy increases or decreases? Everybody? Increases. Understanding?
Yes.
Yes. Again, he is traveling horizontally. His potential energy remains constant.
Constant.
Again, increasing. Again, potential energy increases. Keep it in mind. This total height, the total height is h means, if I calculate this height, let me take h1. This height is h2. This height is h3. So this total height is equals to what? h1 plus h2 plus h3, which is equals to h. Is it okay, guys? All of you? Do you understand? Everybody? Please
Yes,
respond.
sir.
Path. That is why we can say potential energy is not depend on path. It is depends only on what points. It will depend on initial point and
Initial and final point.
final point.
And final point.
Please remember. Okay. Now this question all of you read. Alvin, are you solving? I want response. Make it quick. Make it fast, guys. So labor climbs up a staircase by carrying a load of 10 kg. So let me take some staircase is present. Okay. Now one labor is carrying a load. What is the load of the body? Everybody?
10
Yes.
kg.
10 kg. And the height of
kg.
each step. Height of each step is how much? Everybody?
0.2
0.2
0.2.
meter.
0.5.
And totally how many steps are there?
20 steps.
So
20.
imagine just like each step is 0.2 means then total number of steps are how many? Total number
20.
of steps. All of you. Total
20.
number of steps is equals to 20. Alfin, are you doing? I want to know response. Say, are you writing the classwork? That Hasin is also. Hasin and Princey, madam. Yes, then height of a one step. Height of a one step is how much, guys? I will check the classwork. 0.2 meters. Then can you tell me what is the total height? Total height. Total height, which is travel. Total height is equals to length, height of one step into total number of steps. Am I right or wrong, guys? Please respond. Height of
Yes.
one step. So that's all it is. So which is equals to 20 into 0.2. So can you tell me what is the answer?
4 meter.
4
Yes.
meter.
4 meter. 4
4
meter.
meter.
So that is the total height. So total height is equals to 4 meters. So what is the total distance traveled by the labor? Everybody? Yes.
4 meter.
4
Meter.
meters. Understand,
4
Ra?
meters.
Vedant? The total height traveled by the body from the ground is 4 meters. And he's carrying how many kgs load? Yes, everybody.
10
10
kg.
kg. Now, it is working against to gravity. He is climbing against to gravity. So that work done is equals to something. Anybody can tell? Work done is equals to something. Work done is equals to gravitational potential energy. Am I right or wrong? Because he is going against to the gravity. Yes or no, guys? Which is equals to
Yes, sir.
mgh. That's all. So work done is equals to gravitational potential energy, mgh. M is 10. G value how much? G value is also 10. H value is 4. So which is equals to 10 tens are how much?
400.
400 joules. Okay. So please do it. Units daughter, mass kilogram, acceleration meter per second square, height is again meter. I have already taught you people, which is equals to how many joules? Yes, please. 1 joule.
Joule.
Kilogram meter square per second square is equals to 1 joule. Yes, Agalya, studied or not? Kilogram meter per second square is equals to something. Anybody? Newton. Okay, so please learn it. Kilogram meter per second square is equals to Newton. Kilogram meter square per second square, which is equals to what, everyone? Which is equals to joules. Okay, so please learn it. Do you all understand, everybody? Clear? Sir, why sir here gravitational potential energy? Because he is working against what? Everybody. Working against gravity. So working against gravity means which is equals to energy possessed. Am I right, Mr. Gokul? Kavya? That is what? That is what you have to understand. Hasini Sudhakar, understand, Amma?
Yes, sir.
Yeah, please make it. Complete that question fast, everybody. All of you able to understand or not? Please respond.
Yes, sir.
Sir.
Yeah.
And,
Yeah, please solve it. Lingesh Mudinja Jara. What, Abhirami? What you not understand? Ask
So
me.
one doubt,
Yes, ma'am.
sir. Potential energy is also directly proportional to work done, no, sir.
Yes, not directly proportional, Mari. The amount of work done is equals to energy possessed by the body. Am I right or wrong?
Yes, sir.
Whatever the energy you have, that is what is the work done. So that's what, as he is working against gravity. For example, he is traveling on the surface. See, when he is traveling on the surface, I will say work done is equals to force into displacement alone. But he is going against to gravity. If he is going against to gravity, force is equals to what? M into G. Do you understand it? Understand?
Yes, sir.
So that work done is equals to what? M into G into S. So M into G into S is only ways to called as what? Gravitational potential energy. Am I right or wrong? S means H.
Yes.
Yeah, S means what? H. Because he is working against to gravity. So H will become H. Do you understand?
Yes, sir.
That's all. Clear, everybody? Abhirami, tell me what is your doubt? Don't know how to calculate this. Which one, Amma? You have to know the first total height. You are climbing one step 0.2 meters, two steps 0.2 plus 0.2, three steps 0.2, 0.2, 0.2 height. This all the height is equals to total height. This is H1 and this is H2 and this is H3. Like that 20 steps you are climbing. So 20 steps, each step is 0.2. So the total height is what? 20 into 0.2, you will get 4 meters. That is the total height of the from the basement, Mr. Cooley has been climbed 4 meters height. So then what is the work done by him, they are asking. So work done by him is he is moving against to gravity. So which is equals to force is equals to mass into gravity. Mass is 10 kg he is carrying, gravity is 10. And into height is equals to how much? 4 meters. That's all it is. Understand? Others, everybody?
Sir.
Yeah.
Yes, sir.
Please make it fast.
Finished, sir.
Yeah, make it.
Finished, sir.
Yeah, okay. Next question. Body of mass 2 kg is accelerated from rest to velocity 20 meter per second in 5 seconds. What is the work done and what is the power consumed? Let me see, everybody. Velocity changes. You have to use some energy. What some formula? Anybody can tell me? That I taught you people. Change in velocity is equals to amount of work done. That is only called as some theorem. Anybody? Yes, please.
Work energy.
Work energy theorem. That is what. So a body of mass 2 kg, mass is equals to 2 kg, is accelerated from rest to velocity. So rest means initial velocity is what? Everybody?
No.
0. And final velocity is 20 meter per second. And what is the time taken? Everybody? Time taken is 5 seconds. So what is the work done and power consumed, they are asking. See, they are giving velocity and they are asking work done. So how to find which energy it is? Everybody, kinetic energy or potential energy? It is kinetic energy. So we all people know studied from the work energy theorem. What is the work energy theorem? Revise your notes and tell me. From work energy theorem. No, energy theorem what?
Half M.
That you tell me. No, Mr. Nivedan, I'm asking what is the theorem?
The work done,
equals
the
to-
resultant
Work
force
done of the body
Work done is
set at
equals to.
force acting on
Yes.
is
Work
equal
done is
to the
equals to
kinetic
change
energy.
in kinetic
of the
energy.
body.
Am I right or wrong? Work done is
Yes,
equals to,
sir.
must simplify. I don't want by heart a definition. What is work energy theorem? The amount of work done for changing the kinetic energy. That's what it is. Work done is equals to change in kinetic energy. So that's all. So work done is equals to change in kinetic energy. Change in kinetic energy means what? Final kinetic energy minus initial kinetic energy. So final kinetic energy, what is the formula? Half m where v
Half m
square
v
minus half m
minus
u square.
m
So now, as it is initial velocity is 0, this whole term will become 0. Am I right, everybody? Yes?
yes, sir.
Yeah, please remember the one girl, Kishore responded. Very good, Kishore. Work energy theorem will say simply, yesterday only I told you, change in kinetic energy. We have written or not this one? Very good, Kishore. We have written or not? All of you. That is only called as work energy theorem.
Yes,
What
sir.
amount of work done is equals to change in kinetic energy. That is only work energy theorem. Work energy theorem is not applicable to potential energy. I have taught you that also. Do you remember, everybody? Yes. So as the initial velocity is 0, this whole term will be 0. So amount of work done is equals to half into m into v square. So half into m value how much, Ra? 2 kg into velocity is 20 square. So 2 will get cancelled. So what is the work done? Anybody? Work done is equals to 400.
40.
Half 40, yeah. 20
400
square, girl. 20 square means 20 into 20, which is equals to what is the answer, Ra? 400. Okay?
400.
Let's make it. Now, answer is not at end. Still, there is a question. Work done over. Next, what is that?
Power consumed.
Power.
consumed.
What is the power formula? Work done by time. Am I right or wrong? So work done is equals to 400 joules. Time is equals to 5 seconds. So 400 divided by 5. How much? 5 ones are 5 fours are. Sorry, 5 eights are. So 8 fours are 40. So 80 joule per second. I have taught you people what is the unit of power. Anybody can tell? Unit of power.
Watt.
Unit of power. Watt. So 1 joule per 1 second is watt. So what is the answer?
80 watts.
80 watts. Okay, so solve it. You all able to understand, Mr. Sam? Princey, Mukesh, Kalyan, are you solving? I'll check the notebook this week. I'll say you bye. Mukesh.
Yes.
Yeah.
Sir, we can also say force into velocity, no, sir.
Whatever you can say, Mari, nothing is there, but you have to get the answer. But here we are calculating work done, Mari. See, power is having many formulas. Based upon the given data, you have to use the right formula. Okay. We can say energy by time. We can say work done by time. For example, if I give potential energy, then what is the power formula? mgh by time. Do you understand? Are you clear?
Yes, sir.
Yeah. So you have to be very careful because by the time energy possessed by the body is potential energy. So potential energy is equals to mgh. So energy by time. So potential energy by time. Understand, Amare?
Yes, sir.
Yeah. So formula, many formulas you have to modify according to the given thing. Okay. So this is what. So do it now. This one. Next question. Solve fastly. The cable of an electric motor exerts a force of 30 newtons on a body and pulls it through a distance of 20 meters in 1 minute. What is the power of the motor? That's all. Everybody. They're asking power. It is saying that applied force is 30 newtons and distance is 20 meters. So what else you can say? Anybody? You have to speak loudly. Yeah, we all knows that power
30
is,
Newton
power is
into
equals to what is the
20
formula?
meters.
What is the power is equals to formula? Work done by
Work done by time.
time.
By time.
Yeah, the given force is how much? Given force is how much? 30 newtons. Given
30
distance is how much?
newtons.
20 meters.
Centimeters.
And time is equals to evala.
1 minute 60
One
seconds.
Yes.
1 minute 60 seconds.
1 minute means 60 seconds. So you have to be, you must have presence of mind. So 60 seconds. Then work is equals to what? We all people knows. Force into displacement. or else you can write it directly. So F into S divided by T over. Understand now? I modified or not formula
Yes, sir.
now. So force is how much?
Yes, sir.
20 into displacement is, sorry, 30. 30 into 20 divided by time is equals to what? 60. So I'll cancel.
60.
Yeah, 2 ones are 2 threes are 3 ones are 3 tens are. So anybody can tell me what is the power?
1 watts.
1 na? Wow, super.
10 watts.
10 watt.
Sorry, sorry.
Okay, solve it. Understand others? Everyone? Yes, please respond.
Yes, sir.
Clear? And related to conservation of energy. Related to conservation of energy, this is the question I am giving you. Let me see who will solve first. Related to conservation of energy. Conservation of energy, how to solve this question. So what is there saying? See that. A 2 kg block is dropped from a height of 5 meters. So what is the height, everybody? First of all, what is the height? Yes, please. From which height it has been dropped? 2 kg mass. It has been dropped from which height? Nivedan?
5 meters.
5
5
meters.
meters. That is what. So h is equals to 5 meters. Means 5 meters below something is there. What is that? Ground. Understanding? So now, what is the potential energy and kinetic energy of the block at the height of 2 meters from the ground? 2 meters from the ground, they are saying. Okay? 2 meters from the ground. 2 meters from the ground means what, guys? Everybody. So from here it is. Means it is
We need
already
to find
traveled how much
3
distance?
meters, sir.
It is already traveled how much distance? The distance traveled is how much,
3
Ra?
meters.
3 meters. And here, what it is already above at like 2 meters above from the ground. At this height, let me take it as a, this is H1. At this height, what is the kinetic energy and as well as what is the potential energy they are asking. Okay. So before question, those who not finish it fastly. And then you can, we'll start. Shall we start, guys? Everybody? Conservation of energy. We have to prove it with the numerical. This question completed. Make it quick, Amma.
So, sir.
Yeah. Now, it is at initially A point. Let me take, and this is the B point, which is there above from the ground. So above from the ground, how many meters, guys? Yes, above from the ground, how many meters?
Totally 5
meters.
From the
meters,
ground.
sir.
Above from the ground, first initially at 5 meters. After that, we have to find potential energy and kinetic energy at what point? At 2 meters above from the ground. Okay. So let us see now. First given M is equals to 2 kg, H is equals to 5 meter. Sorry, H is equals to 5
2
meters.
meters.
And H1 is equals to 2 meters. Okay. Now, at A, what is the total energy? Can you tell me? At A, what is the total energy? At A, velocity is 0. So total energy is equals to what? We already studied yesterday. At A, total energy is equals to what? Anybody? At A, total energy is equals to. Please respond.
Sir, you're asking the potential energy, sir.
Yes, Mari. Total energy I am asking. So anyhow, kinetic energy is 0. Total energy is entirely potential. Am I right or wrong? All of you. Yes, yes. Entirely potential energy. Because velocity is 0. So that kinetic energy is what? At point A. Please respond. 2 into 10 into 5. So which is equals to how much, Ra? 100 joules. So at
100
point A, what is the total energy, everybody? Total energy is equals to kinetic energy plus potential energy. So as we know, velocity is 0. At initially, velocity is 0. So that the kinetic energy becomes 0. So by that time, the total energy is equals to potential energy. Am I right or wrong, guys? Please respond.
Sir, then what is the formula for kinetic energy, sir?
Kinetic energy, no formula, Mari. We have to convert energy transformation alone. Understanding?
Yes.
Yes.
Yes, sir.
Yesterday derivation only remember. So at the point A, what is the total energy, guys? Everybody? At point A, what is the total energy? Fastly, everybody.
100 joules.
100 joules. Understanding? Total energy. It is not potential energy. It is what? It is
Total energy.
total energy. Understanding? Now, as a ball falls, its kinetic energy increases or decreases? Ball falls from A to B. It is falls from A to B. Kinetic energy
Kinetic energy increases.
Kinetic energy increases. Potential energy what?
Decreases.
Decreases. Means at point B, the total energy is what? Is it both energies are present? Only one energy is present. I want to know. Everybody.
Sir, only one energy, sir. Kinetic
Hey,
energy.
at point B, Ramari, what you are speaking? It's not reached to the ground. At point B, what energy it is having? It contains both energies. That is what kinetic energy
Yes,
plus
sir.
potential
Kinetic
energy.
energy and
What
Right or
potential
wrong?
energy.
Understood?
Yes, sir.
Yes, sir.
Yes. So please speak. That is what. So at point B, total energy is equals to, it contains both energies, kinetic energy plus what energy? Potential energy. Okay. Now, yesterday also I have told you, potential energy always taken from the where? Height from the what? Potential energy always taken from the what? Ground. Am I right or wrong? So that H is equals to how many meters now?
2 meters.
Ground, 2 meters. So can I write potential energy equals to mgh1? Agalya, understand?
Yes, sir.
Which is
Yes,
equals
sir.
to total energy. So total energy எனக்கு தெரியும். எவ்வளோ joules? 100 joules.
100
Kinetic energy at point B, you can write it at point B. So plus mass is 2 kg, G value 10 and H1. What is the height from the ground? Everybody. 2. So kinetic energy is equals 20.
40.
So 20 into 2, which is equals
40.
to 40. So kinetic
40.
energy at B is equals to 40,
40.
equals to 100. So what is the kinetic energy? Anybody? Kinetic energy at B is equals to
60.
100 minus 40, which is equals to 60 joules. Lingesh
60
already
joules.
solved. Very good, Lingesh. You already solved. Super. So at point B, when the body is dropped from point A, it has reached to the point B. Okay. At this point, it is not reached to the ground. Ground, it is how many meters above? 2 meters
2
above.
meters.
So at this point, what is the potential energy? Potential energy equals to mg from the ground. From the ground only you should take it. What is that? H1. So which is equals to 40 joules. Then at this point, total energy is equals to 100 joules. So total energy is equals to kinetic energy plus potential energy at this point. So potential energy is 40. Total energy is 100. So that kinetic energy equals to how much you'll get it? Everybody.
100 minus 40, 60.
100 minus 40, 60 joules. Next, once it will reach us to the ground,